Alright everybody, I wanted to remind you guys how to be able to work with two-dimensional arrays as well as methods that deal with them. So I'll write a couple examples, and then along the way I'll be reminding you of the different things that we talked about with regards to two-dimensional arrays. So let's just create a simple method here just to remind you what it looks like. Remember that within a class, any application that you create, if it is meant to run as the main code, it should have this main method. This main method, of course, must be separated from the rest of the methods. And here is the header, and the body, of course, is all within these curly braces. If I wanted to create a new method, I cannot begin to put them in here. It's not something that is allowed within the Java world. So again, if I want to create a new method, it's going to be out here. Here's a very simple one, of course, public static hello. Um, so the public and static portions, we'll look into that as soon as we are able to talk about classes and objects. For the present time, let's go ahead and just say that public static are things that we have to add on. So again, please do not get too confused about that. If you really want to, you can always just read about them. But there's nothing going on there that's really gonna, impact the way that you're thinking about arrays and method, just because you don't have an explanation of these yet. We care about the return type. In this case, the return type is void. If it is void, there does not need to be a return anywhere within the body of the method. Of course, the body of the method is going to be all within my curly braces. In this case, I'm just going to go and say I'm going to print something out. Remember that printing something out does not count as returning anything. So you can do that. And then you can have a blank return. However, again, this is not necessary. By default, the program will end as soon as the last statement is reached. I could have another one here, and I'll call this one public static int. In this case, this one is going to return an int. And I'll just call it num. And so this one is just going to return 1 all the time. Nothing special about these methods. Again, I'm showing you guys how you can write methods within a file that you defined as a new application. So essentially what we have here is a class called multi-dimensional array method. It's a bundle of code. The bundle is made up of different methods. So far we've got 3 methods. We've got the main method, the hello method, and the num method. The other confusing thing that people are struggling to wrap their heads around is the idea that these methods that are not part of the main method, of course, they do not run unless you actually use them. We talked about this idea that you are building yourself a toolbox, right? So you've got a toolbox, and each of these methods essentially is a tool. When you've got a toolbox at home, you don't necessarily use all the toolbox. In fact, they don't get used unless you actually physically use them, right? I hope. Sure, somebody will find some sort of counter, but hopefully that will suffice as an analogy to this. So now, if I actually wanted to use these methods, I have to actually use them in my main. And of course, there's a difference between writing the method, which is including the header as well as the body being the logic for that method, and using it as a user, right? So essentially what you could do is you could say, all right, hey buddy, hey friend, if you have those, you can say, I've created 2 methods for you called hello and num. They're all yours to use. So now I'm that buddy or friend, and all I got to do is type in hello. The parentheses here signals that I'm trying to call a method. And of course, I don't need to put anything here because the method was written that way, right? There were no parameters. If you ran this code, of course, now it's going to say hello. So what happens is it encounters the code here. So remember, whenever you run an application, it goes to the main method, and then all the lines of code in there will be executed. So it'll be hello. That's going to go to a part of the code that does this, which of course it prints out and then returns and does nothing. If I wanted to call num, I'll just call num there, and of course num doesn't do anything. It returns a number, but it doesn't print it out. If I wanted to capture whatever number that is, I can just do something like this. So essentially at this point, I know that num returns a number. I'm going to save that number into a variable called x. And then later down the line, I could just go ahead and just print that number out that I captured from the return. And of course, now let's talk about the parameters, right? So another problem that many students are facing is the idea that if you create a method, somehow you're losing the connection between writing the method header and actually using those parameters. So here I'll create another function, another method. I'll call it product. This product is going to return an integer, and then it's going to take in two parameters, a and b. So this method requires that you give it two numbers, right? If it's going to multiply the numbers together, it needs them. So when I'm actually using them here, I'm going to capture the return of that because we know it returns an integer. Now I have to use that method properly according to how I've defined it in the header. This is the header. It says that it takes in two numbers. They're both whole numbers. So I'll give it 2 and 7 or 2 and 5. At this point in time, I've used that method properly. So what if I wanted to have a method that takes an array? Same thing. So public static int sum, right? And what I'm going to do is I'm going to take in an array, and instead of just having the normal int here, I'm going to specify that it's actually an array that's being given to this method, that's being passed. That array is called a. So now within our method, of course, I can use whatever's passed in, and we can just create a simple block of code that will traverse the entire array. And hopefully you guys are familiar with that now. Here's an enhanced for loop. All I'm going to do is I'm going to sum up all those numbers. Of course, let's have a int sum there. So again, this is something you've seen in class already, plus equals x, and then return x at the end of that. Sorry, sum. So at this point in time, the body and the header for this method has been completed. The hard part for you guys, I think, or at least from my observations, is the idea of using it. Well, if you have a method, you wrote that method, and you said that that method needs to take in an array. Therefore, you should probably give it an array if you're trying to use it. So what I'm going to do is I'm going to create an array. 1, 2, 3. All right. So something as simple as an array containing the numbers 1, 2, 3. The idea here is if I'm going to use sum, what happens is I need to give it a one-dimensional array. In this case, the array that I have is called my array. What happens is as soon as you pass my array onto sum, it's actually seen by the method as a. So in this case, you're passing in my array. That's the name of the array. However, in sum, it is referred to as a. The name of the array that you give it does not need to match the name of the parameter here. So you could call this my array if you really wanted to match them up, right? You could call it num. But we'll stick with a just to show you that my array here now has been renamed, and its new alias is a. They are referring to the same array. However, again, it's just has been renamed. So now let's do another one. Maybe this time around I'll take in an array as well as another number. So public static int sum int a, and then some random number. So in this case, I've got a method that takes in two parameters. It's going to take in an array, and then it's going to take in a normal primitive type. A primitive type is just a data type that can only hold one thing at a time. An integer, for example, can only hold one number at a time, right? So it's called a primitive type. In this case, if I wanted to use this other version of sum, then I would have to say that I should use the one that has two parameters, right? My array, and then it takes in another number. It could be whatever number. So again, if I'm trying to use sum, I'll call it sum2 in this case. I need to give it an array as well as a number. Just to wrap up real quick, I'm giving you examples on how to use a method and how to write a method that does not have a return type and does not have any parameters. And then we went over and talked about how you can have a method with a return type and with parameters. If it has a return type, somewhere in the body there should be some return statement returning that type, right? So a times b is going to be an integer, and we're returning that. And then we moved on to one-dimensional arrays. This one right here, we've got a method called sum. It takes in an array called a, and then just does this, and of course it returns a whole number, int. And then from there, if we were trying to use these methods, for example, we're going to use sum, in the way that we have written it, right, it matters. You have to pay attention to your header. The header says that this method has been written such that the parameter must be an integer array. Therefore, if I'm trying to use it, which I'm trying to use here, I need to give it an integer array. I have an array here called myArray. It is an integer type. And so it's legal for me to say, all right, sum of myArray. So now the other confusion was, well, you call it myArray there, and then in the method it's called a. Well, what happens is it sees this line of code and it knows that it has to call this method. It goes to that method, and whatever variable name you passed it, right? Whatever name you gave your one-dimensional array, essentially it's going to be renamed to a. So essentially you're allowing a user to create whatever name they want for this method when they're using it. So that you don't want to restrict a user in how they want to name their variables and their objects. And so essentially what you're doing is whatever array you give me, I'm going to refer to it as a. So that's what's happening. So my array has been sent to this thing called sum. However, for the purpose of the calculations within this method, whatever array is passed in is now being referred to as a. So those were some of the misconceptions and holes in the logic. And then finally now, how do I deal with two-dimensional arrays? So here I have a two-dimensional array. My 2D is equal to, well, let's go ahead and just set it. New int 2, 2. Excuse me. So in this case, I have a 2 by 2 matrix, and I'll go ahead and just set one of them, the values up, because I know that I can access individual elements using the bracket notation, right? So my 2D, for example, if I wanted to access the elements at row 0, column 0, remember the order is R, C, row, column, I'll set that value to be 5. And if I wanted to access the element at 1, 1, which is at row 1, column 1, I'll go ahead and just give them the proper, give this the proper coordinates, and it should set those up properly for me. So now I have myself a two-dimensional array. There are different properties that we talked about. One of them is, if you have a two-dimensional array, how do you find the number of rows contained? And to do that, all you need to do is actually call the name of that array. So in this case, it's my2d, and then call the length property. This will return the number of rows for a two-dimensional array. So again, just make sure if you need to memorize it, go ahead and do so, but you have to know that if you are calling the name of the two-dimensional array and then using the dot operator and calling the length property, you are calling for the number of rows. If you want to get the number of columns in a given row, what you can do is you can refer to that specific row. In this case, let's refer to the first row, or at index 0. Indexing still begins at 0. Doesn't matter if you have a one-dimensional array or a two-dimensional array. So in this case, what we're doing here is we need to figure out how many elements there are in a row. In this case, the row is the row at index 0. So that's what this is getting, right? Get number of columns, or elements in this case, in row 0. If you wanted to get the number of elements in row 5 or row 1, since row 1 exists here, you'll just go ahead and say, all right, my2d at 1. So again, what's happening here is you're grabbing a specific row and you're going to go, all right, how many elements do you have? But in this one, you're going to go, all right, let's call our two-dimensional arrays. If you do the dot length on that array, it's going to give you the number of rows. So as far as syntax goes, one has brackets, and then the other one does not, right? The other one grabs a row, specific row. And now let's go back to methods. If I have a method that's going to iterate through a two-dimensional array, then I have to specify that it's going to be grabbing, or it's going to be taking in a two-dimensional array. So I'll just do a simple one, public static int sum. This time around, if I want to specify that it's going to be taken in a two-dimensional array, I'll just use two brackets here. Much like how you would define it with two brackets here when you're creating the array. Now you're just saying A is a two-dimensional array, and that's specified by having two sets of square brackets. So here, let's go over an example of how to traverse the two-dimensional array and sum up all of the elements. We'll start with having a sum of 0. And then what we're going to do is have a for loop that's going to change the row. And then we'll have another one that's going to be changing the column. So here, I'll show you int row is equal to 0, how to change the row, of course. From up here, we know that to get the number of rows, we need to use this syntax. And of course, here we're referring to A, we're not referring to my2d. Row plus plus. All right, so in this case, if you have a two-dimensional array, what's going to happen is it's going to iterate through every single row, starting at row 0. So I'll give some example, maybe showing you what it looks like. So let's say I've got an array that's 2 by 2, and these are the values. What's happening is that for loop is going to go refer to that row first, which is row 0, and then it's going to refer to this row next. However, when you're referring to a single row, the next thing you want to be able to do is, for a given row, you want to be able to access the individual elements, right? So, sure, you found the first row. Now what? Now we need a second for loop that's actually going to iterate through that row. And we'll just call it column. The column starts at 0. Column is less than a of row dot length. A plus plus. Oops. Column. So at this point in time, this inner for loop is going to start over here, and then it's going to change the column number. Yeah. It's the same thing as traversing a one-dimensional array, essentially. So at this point here, I'm going to go sum plus equals. We're going to grab the element at this very specific row and column combination, or at a row call. So if we're looking at this code, we know that at the very start, we have a for loop that will set row to begin at 0. And then for the entire time, for that entire iteration, we're going to have a for loop that's going to be changing my column. So this is the code that we have here. If we go back in Excel to kind of look at how this works, here's my array, right? We know I have an outer for loop called row, and we started at 0. And we have an inner for loop that will be changing column that starts at 0. So in that inner for loop, we start here, and then after that we go through again. Because we have a for loop, this is going to, of course, repeat until this is no longer true over here at this condition. So going back here, essentially that outer for loop says to start at row 0, and then the inner for loop says to start at column 0. The second iteration, column is going to increment, but row is not going to increment. So the row is only going to increment as soon as this entire for loop is over with. And when that entire for loop is over with, of course, I would have traversed an entire row. If I increase the size of this, it's going to go, all right, let's start at row 0, and then the inner for loop is going to go, all right, row 0, column 1, 2, 3, etc., etc. As soon as that's done, that inner for loop is going to end because this is no longer true. You run out of columns, and you go back up and say, all right, now I'm going to increment row. As soon as I increment row, I run this for loop again. In this for loop, again, we start at column 0. So now I increment row, and then column is reset to 0, and then column is going to increment because of that for loop. It's going to go here, and then here, etc., etc. So this is very similar to the prime number generation that you guys worked with, where you had possibly an outer for loop that was changing the factors that you were dividing by, or something to that effect. And then you had an inner for loop checking whether or not, the numbers that you had were divisible by that number. So at the end of this, of course, this method, don't forget your return types, because we have a return type of int, which makes sense in this case because all we're doing is we're summing up a whole bunch of whole numbers. We're going to return the sum. The sum was my accumulator, which is right here. Add this element to sum. So there you have it, kind of a simple overview of what we discussed so far with two-dimensional arrays. Remember that first number stands for the rows, the number of rows, and then the second number stands for the number of columns. So here, this is going to be a 2x4 matrix. And then you can access individual elements using their coordinates. So 0, 0, we're setting to the value 5, 1, 1, 1, 2, etc., etc. And of course, you have to remember that indexing still starts at 0 for two-dimensional arrays. And then we kind of had a review of how to use these methods. So we wrote a method called sum that will be using a two-dimensional array. In this case, my array is called my2d. So now I'm going to try to use my2d. Remember, this does not run unless you call it within the main method. So the name of the method is called sum. It takes in one parameter, and it is an two-dimensional array. The two-dimensional array that I want to give it is called my2d. And that's it. So again, when the program executes and runs, as soon as it gets to this line, it's going to go, all right, I'm going to go to this method called sum that takes in a two-dimensional array, which is over here. And then whatever array is passed into it, I'm going to go ahead and just refer to it as A. Because, you know, the user could have called it blah, the user could have called it my array, but doesn't matter. Whatever's passed in this case it's called my 2D, I'm going to refer to it as A. And so that's what we have here. We're referring to whatever's passed into this array as A. And there goes a summary of so far what we've done. Hopefully this was helpful for those who were a little bit confused about using methods and arrays, etc. Okay, how do I escape this again? I always forget. There you go.